Everyone, welcome to this video. It's on trig identities. There's only going to be this video on trig identities. We're going to go through it real quick. It shouldn't take that long. Anyways, an identity is an equation that's always true. So it's kind of like a theorem, but a theorem is an if-then statement. So if this is true, then this is true, kind of thing. Whereas an identity is an equation, so it has an equal sign. We're going to be verifying identities. It's kind of like proving the verification. It's just we're only using algebra because we're using equations. Some identities are considered trivial, like this one right here, x equals x. It's called trivial. Now, this is always true, and it is an equation, so it's an identity, but it's trivial because it's kind of like, yeah, no duh, right? It's reasonable. It's common sense that a number equals itself. Okay. And then there's identities like this. Pythagorean theorem, a squared plus b squared equals c squared. Right? That's an identity. It's always true for right triangles. But it's not trivial. Right? It's not like it's common sense where it's, yeah, obviously a number equals a number. This had to be discovered, right? It had to be proven, so it's not trivial. So let's just jump into some of the identities. There's some identities you already know. You just didn't know what identity was, and so we called them definitions. Okay. For example, cosecant of theta is 1 over sine. And secant of theta is 1 over cosine. And cotangent of theta is 1 over tangent. Okay, those are identities. It's always true. And we all know this, that cosecant is the reciprocal of sine, secant is reciprocal of cosine, cotangent is reciprocal of tangent. Okay, remember when it's 1 over, it means reciprocal. That's by definition. 1 over something is reciprocal. So these are called reciprocal identities. And it's a definition that you should already know. Here's some other ones. Tangent is sine over cosine. And cotangent is cosine over sine. Okay, you should already know those definitions, but they're now called identities, right? They're an equation, it has an equal sign, that's always true. These are called the quotient identities. Okay, you can see it's division, sine divided by cosine. And yes, I understand that we're dividing here, but when it's 1 over, by definition, it's not just division, it's reciprocal. Okay. So those are 5 identities that you should already know from quarter 3. If not, then you need to work on quarter 3. Okay. Now we're going to look at 6 other ones, and you'll want to memorize these or just know how to get them. So first off, let's look at this unit circle here. So from SM2, you learn that the equation of a circle is x squared plus y squared equals r squared. Okay, where r is the radius. Well, if I'm looking at the unit circle, x is the cosine, y is the sine, and r is the radius, which is 1. Well, I have a parametric equation set up here. So let's plug in. Instead of writing x, I'm going to write cosine. So we got cosine squared plus y squared, so sine squared, equals 1 squared, which is 1. That's your first identity. All right, so it's one of the 3 Pythagorean identities. All right, and that's how we come across it. It's called Pythagorean because on the unit circle, when we have a right triangle, we have a squared, which is cosine, plus b squared, which is sine, equals c squared, which is the radius. Right, so right here, cosine plus sine is radius. So that's the first of them. Now, to get the other 2 is actually really simple. We take this original one. So for example, cosine squared of theta plus sine squared of theta equals 1. And let's divide everything by cosine squared of theta. Okay, we're allowed to do that because properties of equality. As long as you divide to both sides of the equal sign, then things stay equal and things stay true. Well, cosine divided by cosine is 1, right? Number divided by itself, plus sine over cosine. We have our quotient identity says it's tangent, so tangent squared of theta equals 1 over cosine. Reciprocal identity says that it's secant squared. Okay, that's the other Pythagorean identity. Now, instead of dividing by cosine, what if we divide by sine? So let's see here, cosine squared plus sine squared equals 1. So what if I divide everything by sine squared? I'm still allowed to do that, right? Because it's property of equality. Whatever I do to one side, I do to the other. Well, cosine over sine, the quotient identity says that's cotangent squared. Plus, sine over sine is 1, right? Number divided by itself is 1. And then 1 over sine, reciprocal identity says it's cosecant. And there's your other Pythagorean identity. Okay, these are special because it uses all 6 trig functions. Sine, cosine, tangent, secant, cotangent, cosecant. It uses all 6 trig functions in the Pythagorean identities. So like I said, either memorize these or know how to get to them so you don't have to memorize them, but one or the other. Now let's look at double angle identities. Now the double angle identities, the way to prove it or to verify it is we have to use another identity, which we're not going to teach you. So you're just going to have to trust me that a couple of these steps that you're going to be like, well, I don't know, how'd you do that? They are identities that you haven't learned and we're not going to teach you. But the calc teachers want you to know the double angle identity, so catch 22. Anyways, so we have a sine of 2 theta. This is called a double angle identity because you have an angle and you double it, right, times 2. Well, sine of 2 theta is equal to sine of theta plus theta, right? If you have 1 theta and then add another one, you have 2. So theta plus theta. Now there's an identity called the angle sum identity. And this is going to be sine of theta times cosine of theta plus cosine of theta times sine of theta. Okay, that's the angle sum identity. Now, sine times cosine, we have 2 of the same terms, so it's 2 sine of theta cosine of theta. And that's sine of 2 theta. Okay, so that's a double angle identity for you. Now, with cosine, its double angle identity, there's actually 3 forms. Okay, there's 3 forms. So once again, we're going to go cosine of theta plus theta. This angle sum is cosine theta minus sine theta times sine theta. Okay, a number times itself is squared, so we got cosine squared theta minus sine squared theta. And that's the first form of the cosine angle double angle identity. Now be careful, this one's minus. Okay, the Pythagorean identity is cosine plus. This one's minus, so don't get those mixed up. Okay, now speaking of the Pythagorean identity, Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Well, what happens if I subtract sine squared from both sides? Then I have cosine squared theta equals 1 minus sine squared theta. Okay, well if cosine squared equals this, I'm going to take this and plug it into cosine squared here. So then we have that cosine 2 theta is equal to, instead of cosine squared, I'm going to plug in 1 minus sine squared. 1 minus sine squared theta minus sine squared theta. So cosine of 2 theta is equal to 1. And negative 1 minus 1 is negative 2. So negative 2 sine squared theta. That's the other form. That's another form of cosine double angle. And then we got one more. So once again, come back to our Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. This time, instead of subtracting sine, what if I subtract cosine? So sine squared of theta equals 1 minus cosine squared of theta. So this time I'm going to take this, and instead I'm going to plug it into sine instead of cosine. So then we have cosine 2 theta is equal to cosine squared theta minus, and instead of sine squared, I'm plugging in 1 minus cosine squared. 1 minus cosine squared theta. Distribute the negative. Cosine 2 theta equals cosine squared theta minus 1 plus cosine squared theta. 1 cosine plus 2 cosine, or 1 cosine plus 1 cosine is 2 cosine. So cosine 2 theta equals 2 cosine squared theta minus 1. Okay, that's the other form of your double angle cosine identity. Okay. Now we got one more, do tangent. So let's see here. Tangent of 2 theta. Well, by the quotient identity, we know that tangent is sine over cosine. And we just figured out what the sine double angle identity is, so let's plug that in. It's 2 sine theta cosine theta over, and we know that we have a cosine double angle identity. We're going to use the first one that we found. Cosine squared theta minus sine squared theta. Now I'm going to divide numerator and denominator by cosine. This is going to set our identity up to get in terms of tangent. So I divide the numerator by cosine and the denominator. Okay. Well, here in the numerator, oh, sorry, this is cosine squared. Should be cosine squared. In the numerator, one of the cosines reduce. So I'm up with 2 sine theta over cosine theta. In the denominator, cosine over cosine is 1, minus sine over cosine, which is tangent. Okay, and then in the numerator, sine over cosine is tangent, so 2 tangent theta over 1 minus tangent squared of theta. And that's the double angle identity for tangent. Okay, let's flip the paper over to the next side. We're going to verify some identities. Now, when verifying identities, It's kind of like a proof, but we're doing it algebraically. When verifying identities, you can only work with one side. Okay, you're not allowed to, for example, let me go to this first one. 1 plus cotangent squared of theta equals cosecant squared of theta. You're not allowed to use any properties of equality, like subtracting 1 from both sides or dividing both sides by sign or whatnot, because we don't know if it's equal yet. That's what we're verifying, that it really is equal. So since we don't know it's equal, we're not allowed to use properties of equality because we don't know it's equal. So you can only work with one side. My suggestion to you is work with the side that's more complex, right? You're all used to taking something that's complex and simplifying it. That's what you've been doing your whole math career. Taking something that's complex, simplify it. Right, so that's what you're used to. It's harder to take something that's already simplified and then make it more complex because there's 1,000 different ways to do it. And there's only one specific way to get it to here. So there'll be a lot of guess and check. So I recommend starting with the complex side, simplify it down. What we want to do is get one side of the equal sign to look like the other one. Because then we have a trivial identity where a number equals a number, and that's always true. Okay. So if I can prove that a number equals a number through verification, then the identity is true. Okay, so this is kind of what we're going to do. I want to get this side, the more complex side, to look like cosecant squared. By using identities I already know, so the stuff on the front page. Okay. Let's see, and some algebra techniques that apply to just single sides of equal signs. Well, cotangent is cosine squared over theta, or cosine squared of theta over sine squared of theta. Okay, I know that cosecant is the reciprocal of sine. Well, I want to get things in terms of sine so I can eventually get to cosecant. So I'm not going to use cotangent. I'm going to try to get sines going. All right, well, I only have one term here, so I want to add these together to get one term, but I need a common denominator. So I'm going to turn 1 and get it to have a common denominator. Okay, sine over sine is 1, but it has a common denominator now, so I can add fractions. So sine plus cosine. Now, Pythagorean identity says that sine squared plus cosine squared is equal to 1. So the numerator is now 1 over sine squared theta. Okay, this is a reciprocal identity. It says that 1 over sine is equal to cosecant. Verified. Cosecant is equal to cosecant. And we're done. Okay, we just proved that this identity is true. I guess verified it. Wasn't a formal proof. Let's do the next one. This one's very similar. 1 plus tangent squared of theta is equal to secant squared of theta. Once again, I'm going to change tangent to sine over cosine. I'm going to get a common denominator with the 1, which is cosine squared. I'm going to add my fractions together. Okay, now once again, Pythagorean identity says that cosine squared plus sine squared is equal to 1. So 1 over cosine squared theta. Reciprocal identity says that 1 over cosine squared is secant squared of theta. And verified. Secant squared equals secant squared. Let's do this one. Tangent of theta times cosine of theta equals sine of theta. Okay, well, tangent is sine over cosine times cosine. Cosines cross reduce. We're left with sine theta over 1. Sine, anything over 1 is itself, so sine theta. And verified. Sine is equal to sine. All right, this comes down. Okay. All right, next one. Cosecant theta times cosine theta times tangent theta is equal to 1. Well, cosecant is 1 over sine theta. Cosine stays the same. Tangent is sine over cosine. Well, here the cosines reduce, cross reduction. The sines cross reduce. So we're left with just 1. So 1 equals 1. Verified. Okay. Secant squared of theta minus 1 over secant squared of theta equals sine squared of theta. Okay? Well, secant over secant is 1, and then minus 1 over secant squared of theta. Well, 1 over secant squared, the reciprocal identity says that that's equal to cosine. So 1 minus cosine squared of theta. Now, if we look at our Pythagorean identity, sine squared plus cosine squared equals 1. If I subtract sine squared or cosine squared from both sides, it says that 1 minus cosine squared, which is this, is equal to sine squared. So this is sine squared. Verified. Let's do cotangent of theta over cosecant theta is equal to cosine theta. Okay. Well, cotangent is cosine over sine. And cosecant is 1 over sine. Okay, when you divide by a fraction, you multiply by the reciprocal. So then we have cosine theta over sine theta times sine theta over 1. The sines cross reduce. So then we have cosine theta verified. Okay, now we got a couple of double angle ones. Secant 2 theta is equal to secant squared of theta over 2 minus secant squared of theta. Okay? Let's see. Secant squared is 1 over cosine squared. That. Let's multiply numerator denominator by cosine squared. I'm allowed to do that. I didn't cross the equal sign. Well, this is divide by cosine, this is times by cosine, so they reduce, so you're left with 1. Okay, then 2 times cosine squared is 2 cosine squared. Minus cosine squared, or times cosine squared, divide by cosine squared, they reduce, or they undo each other, left with 1. Now this right here is one of your cosine double angle identities. So this is 1 over cosine of 2 theta. Reciprocal identity says that this is secant. So secant of 2 theta. And it's verified. Okay. Last one here. One minus 2 or cosine 2 theta. Okay, so we got that right there. Let's see here. Let's work with this side first. We're going to end up working with both sides. We're not going to cross equal sign, but we're going to simplify this down to something, and then we're going to simplify this down to the same thing. Okay, so we're going to work with each side individually. We're not going to cross equal signs. So tangent is sine over cosine times, now sine of 2 theta, that's one of your double angle identities. It's 2 sine theta cosine theta. Well, cosines reduce. So you're left with 2 sine squared of theta. Okay, we're going to end it right there. Now we're going to switch over to the other side and see if we can simplify the other side. Well, cosine of 2 theta, one of the forms, right? We want to try to get sines, so I'm going to use the form that has the sine in it, the 1 minus 2 sine squared. Okay, distribute the negative. So I got 1 minus 1 plus 2 sine squared of theta. 1 minus 1 is 0. So 2 sine squared of theta equals 2 sine squared of theta. Verified. Okay. And that's all there is to it. These double angle identities will be the most difficult ones that you'll get. Okay, like on that's the upper tier of difficulty, like on a quiz. These ones right here, this one and this one, these are the easiest. These is like the easiest ones that you'll get on a quiz. Okay. That's it for the video. Okay, remember you need to memorize these or just know how to get to them. Let me know if there's anything I can do to help you out.